Previously, we have discussed pseudocode, we have discussed a bit of Python programming, and we have discussed certain fundamental aspects of NumPy, especially generating one-dimensional array. NumPy creates one as well as multi-dimensional arrays, and also it brings vectorized operations. So in this lecture, we will start with indexing and slicing of 1 and 2 dimensional arrays, and we will talk a bit about vectorized operation. NumPy itself is a big subject. It has large number of functionalities. It's a very powerful tool, but we are not going to learn everything. That is neither necessary nor possible for us. So I will only talk about few features which may be useful in this course, and as you go along, you will learn some more of your own. And let's start with creating an array. In this particular lecture, it will be best if you keep on typing what I am typing on screen. So what we are doing now, first we are creating an array A which starts from 1 and ends at 6 minus 1. So let us first create this array. So we have created this array 1, 2, 3, 4, 5. Now in an array, all these items that you see 1, 2, 3, 4, 5, they are indexed. So they have a serial number. That's what we mean. And this indexing in Python, it starts from 0. So here our array is 1, and this array is an index that will go from 0, 1, 2, 3, 4. An index also can come backward. The last item in Python can be indexed as -1, then it is -2, -3, -4, and -5. So this is how this array A is indexed. Now when this is how it is indexed, any item we can call it by its index. So the take-home message here is that index starts from 0. In some languages you will see that the array index starts from 1, but in Python index starts from 0 and index starts from -1 at the end. So when taken in reverse direction, index starts from -1. Now I want to print some element of this array. Let us say that I want to print this 3 of this array. I have this 1, 2, 3. Then I have to call the index. So what is the index of 3? Index of 3 is 0, 1, 2. Okay. So we invoke A2 and it gives me 3. But then you wonder that why it is 2. We can write that its index is -3. So let's see what happens if we invoke -3. You can see that it is giving me 3. So every member in this array, they can be invoked from this 0, 1, 2, 3, 4, one of them, or from -1, -2, -3, -4, -5, one of them. Both are all right. Now let us go for slicing. If I want to take a small part of this array, that would be a smaller array. So let us say that I want to take this part, let us say this 1 and 2, first two items I want to take. So that is what is called slicing. And so the slicing, I want to take this 1 and 2, first two items. For slicing, what we do is we use any particular array, let's say this, and we write this slicing as A start stop. So what does this mean? Let us see. So the default values, default start is 0, stop is last index plus 1, and step, the default is 1. What does that mean? Let us see. So for instance, we want to take this 1 and 2 from this array. So we write this A, 1 is 0, 1 is indexed at 0, what you can see here. So we have 0, then 2 is indexed as 1, so I will write 2 here, and then of course step is by default it is 1, so I don't have to write step. I can write 1 or I don't have to write step. So you can see that it is giving me an array 1 and 2, first 2 items. When I slice it, 0, 2. So now I take this A2 start, sorry, A2 colon, and here this 2 is the start. Since it is the start, it gives me an array 3, 4, 5. So 2 is the start, item number 2 is 3, item number 0 is 1, item number 1 is 2, item number 2 is 3. So it is starting from 3 and then it is going all the way up to the last item, 3, 4, 5. If I say A colon 2, that means my start is default, stop is default, step is 2. So it will go from this 0 to 4. It will take all the items with a step of 2. So let's see. It is taking 1, 3 and 5 because it is jumping 1. Similarly, we can go with this negative indices. So for instance, I write -2 star. So it starts from -2 and then the step, default step is 1, so it can go only up to -1. So you can see that it is taking 4, 5. So it is starting from -2, default step is 1. So starting from -2, it will go all the way up to the end, and it ends at this -1, that is 5. And let us say A -1 -3, it will not go -1 to -3 unless the step is negative. So I give a step of -1. So it will start from -1, that means 5. It will stop at -3, so it will not include -3. That means it will start from 5 and it will stop at 4. So the array should be equal to 4, 5, just like the previous one. Sorry, the array should be equal to 5, 4 because it is starting from -1. So this is how we slice one-dimensional arrays. Now let us look at the vectorized operation of 1D arrays. So let us say that I create 2 arrays. So A equals np.arange. Here I was taking 1 to 6, so we take here 1 to 5, and we take another array B, which is np ones, and I take this size 4. So what is A then? A is 1, 2, 3, 4. What is B? B is 1, 1, 1, 1. Now C equals A plus B. If I write this way, and then I try to see that what is my C. You can see that C is becoming 2, 3, 4, 5. These are term by term addition. So this is an example of vectorized operation. So we are operating over arrays. We are adding two arrays just like we add two numbers. These operations are done simultaneously. It's not one after another. We can use a for loop and we can do this operation one after another. But here these operations, they work simultaneously. That is why this operation is fast. So just like this A plus B, we can take C equals A multiplied by B. This multiplication, once again, let's see what it is. You see this is 1, 2, 3, 4. So this is an example of term by term multiplication. Just like this, we can have a multiplication by a scalar. Let us say C equals 2 multiplied by B. You can see this is 2, 2, 2, 2. So this is a scalar multiplication. My B array is 1, 1, 1, 1. Each of these terms have been multiplied by 2. So this is a scalar multiplication. Now we can write D equals A divided by C. And what is my D then? So it is still an array. My A array was 1, 2, 3, 4, 2, 2. So this is a term by term division. You can see 1 divided by 2, 0.5. Then 2 divided by 2, 1. 3 divided by 2, 1.5. And 4 divided by 2 is 2. So this is term by term division. We can also write this D equals A double slash C. I hope you remember that this is the integer division. And what will happen to D now? Well, the first term is 1 divided by 2. Second term is 2 divided by 2, that is 1. Third term is 3 divided by 2, that will be 1 point something, so 1. And fourth term will be 4 divided by 2, that is 2. So now this is my D. And if I take this A once again 1, 2, 3, 4, and I take this C equals A to the power 2, this is A multiplied by A. Once again, this will only mean term by term squaring. So this is 1496. My A was 1, 2, 3, 4. So my square is 1496. So this is a term by term multiplication. There are many similar operations that we can use NumPy to do it. So for example, A dot, or let us say C. C is now my 14916. C dot min is 1. So among these 4 elements, the minimum is 1. C dot max is 16. And if I add all of them, 16 plus 9, 25 plus 5, that would be 30. So C dot sum, that is 30. Let us now go toward two-dimensional arrays. They are very similar to 1D array, but it is more complicated to understand physically. So let us see how they are. So in two-dimensional array, we define this array as, two-dimensional array is actually list of lists. Multi-dimensional all arrays are list of lists. So let us say this is 1, 2 is one of them, 3, 4 is another. So let's see, we have written it right, I hope. Yes. So now I have a two-dimensional array. So this is what we know as matrix. So this is a matrix. I have 1, 2, 3, 4. I have 2 rows and 2 columns. Here also, just like we have discussed in case of one-dimensional array, here also we can have zeros and ones, etc. So for example, b equals np dot zeros and 3 2, which means it will give me an array of zeros with 3 rows and 2 columns. You can see all zeros, 3 rows and 2 columns. If you are trying to have an identity matrix, then you have b np I 3 3 will give me a square matrix size 3 identity. You can see that the diagonal terms are 1, everything else is 0, 3 rows, 3 column. You can have full matrix like what we have seen before, b equals np. So this will be a matrix with 2 rows, 3 columns, and all the elements will be. Now in case of a two-dimensional matrix or two-dimensional array, this A, I have 1, 2, 7. This is an arbitrary matrix. I am writing 3, 4, 3. So let us say this is an arbitrary matrix. Then I take this as axis 1 and we take this as axis 0. This is how Python assigns the index in two-dimensional array. So now for any element here in this matrix A, I, J, then I is the axis 0, this is the axis 0, and J is the axis 1, which means this A00 item here will be 1, this one. A01 item here will be 2. A02 item here will be 7, etc. Let us create this matrix and see what happens. So A1, 2, 7, B3, 4, 3. Let's check what is A. So I have this 1, 2, 7, 3, 4, 3. I have this A dot sum. It will sum everything. Everything together will be 20. 1 plus 3, 4, plus 6, 10, plus 7 plus 3, 10. So everything together is 20. I can also have axis wise sum. A dot sum. Axis equals 0. It gives me 4, 6 and 10. So 1 plus 3, 4, 2 plus 4, 6, 7 plus 3, 10. It is summing over axis 0. Axis 0 is in this direction, so it is summing over axis 0. So this A dot sum axis 0, we can say that it is summing over axis 0, which means this I index. So this is summation of Aij summed over I only. But A dot sum, this is actually summation of I, summation of j, Aij. This is summation of everything. So in the same way, you can have this sum over axis 1. So it gives me 10, 10. So 10, 10 means 1 plus 2 plus 7, I'm going in axis 1. So this is 1 plus 2 plus 7, that would be 10. 3 plus 4 plus 3, that would be again 10. So it is giving me an array of 10, 10. So from 2D array, I am coming to 1D array. So when it comes to axis 1, then this is Aij summed over j. So let's create a slightly bigger matrix then. Let us say that we create a 4 by 4 matrix. So I'll have 1, 2, 3, 4, then 5, 6, 7, 8, 9, 0, 0.1, 0.2, and 0.3, 0.4, 0.5, 0.6. So I have created a 4 by 4 matrix. Let's see, we have written it right. No, we made a mistake here. Yes, so after 0.5 we forgot a comma. Yes, so now we have our 4 by 4 matrix. In this matrix, the axis 1 is the horizontal axis, axis 0 is the vertical axis. Now how do we index this? So we have this 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0.1, 0.2, then 0.3, 0.4, 0.5, 0.6. So this is my overall matrix. I index along this axis 1 as, so my axis 1 is indexed as 0, 1, 2, 3, or it could be in reverse direction. So minus 1, minus 2, minus 3, minus 4. Here I have 0, 1, 2, 3, or minus 1, minus 2, minus 3, minus 4. This top row could be row 0 or row minus 4. They mean the same. The second row is either row 1 or row minus 3. They again mean the same, etc. Column wise, the first column is either column 0 or column minus 4. They again mean the same. So let's just check that we are doing a right thing here. So for example, A3, 3. So this is 3, this is 3. So A3, 3 is this item 0.6. So let's just check once again that we are doing the right thing. So print A3, 3. This is 0.6. But 3, 3 again, you can see that this 3, 3 is the same as minus 1, minus 1. So let's just see that if that is right. You can see that it is still printing 0.6. So we are right here so far. You can check further. A2, 2. This is 0.1. So 2, 2. This is 2. This is 2. This is 0.1. And here this should be same as, this is 2, this is 2. So this should be same as minus 2, minus 2. So let's check if it is indeed same. This is minus 2, minus 2. This is 0.1. So we are doing it all right. Now let us do certain slicing. So slicing is very similar to that in one-dimensional arrays. So for array A, we create a smaller, let's suppose 2 by 2 array out of this 4 by 4 array. So I do the slicing as A, 1, 3 and 1, 3. So what it will bring, let us first check it. 1, 3, 1, 3. So it will start from 1, it will go less than 3, it will just stop at 3. So it will take from row 1, row 2 and column wise also it will take column 1, column 2. That means this 6, 7, 0 and minus 1, that should come here. So this is, we print this B. So you see B is a 2 by 2 array. This is 6, 7, 0 and minus 1. So now we can play around with it, and so let us say that we take B equals A 1, 3, 1, 4. So what will happen now if I print B? So it will go from row 1 and it will stop before row 3. So it will take row 1 and row 2. It will be in these two rows, and column wise it will go from 1 to 4. It will stop before 4. That means column wise it will go from 1 to 3, which means this 6, 7, 8, 0, 0.1, 0.2, these terms will be taken up, which means this will be an array of 2 rows and 3 columns. So let us check. So you can see that this is 6, 7, 8 and 0, 0.1, 0.2, that is coming as it is expected. Now let's check with a minus. So let's keep this 1, 3, but in B we keep it minus. So I take this minus 2 to minus 4. If I take minus 2 to minus 4, I have to give a minus increment. So the increment is minus 1. What happens here? 7, 6, 0.10. So minus 1 to 3 means these 2 rows it will be taken, and minus 2 to minus 4, that means these 2 columns will be taken. So this coming from 7 to 6, 0.1 to 0. So you can see that we can create lots of small arrays by slicing a bigger array. We'll now check some simple linear algebra operations, because these matrices and vectors, as you know, they are integral part of linear algebra, and you will see that using NumPy we can have very easily can operate the typical linear algebra calculations. So let us say we are interested to find the inner product of vectors or dot product of vectors. So for that we once again take 2 one-dimensional vectors just like this. Just keeping this simple, I'm taking it smaller, 1 to 5, and this is my u vector, and my v vector is, it starts from 5 and it stops 5, 6, 7, 8, so it stops at 9, and we are interested to find this u dot v, or what we write this u transpose v. So let us first see that we have written it properly. So u is array 1, 2, 3, 4, v is array 5, 6, 7, 8. They are of same size, so we can have a dot product in fact. So the dot product is u at the rate v. And you see that this is coming to be 70. So this is 5 plus 12 plus 21 plus 32. You add them up, it will be 70. You write it at u at the rate v, or we can write it as print np dot, because this is the inner product, u v, it is 70. So dot product is also called inner product. However, if we have an outer product, or then it will be u v t, that kind of an operation. So this would be with a vector row vector multiplication. It will give us a 4 by 4 matrix. So for that, this is an outer product. So this is np dot outer u v. And you can see that this is giving me a matrix. Similarly, we can have matrix multiplication. So for instance, we define two matrix first. I have A and a similar matrix. We take B and we can multiply these two matrices with a very similar notation at the rate. And this will be 19, 22, 43, 50. You can check this multiplication. In the same way, we can have a matrix vector multiplication with A matrix and let us say this V vector. If I have, then I can have A at the rate V, that will give me matrix vector multiplication. So this is how we can carry out a large number of linear algebra operations. And as we go along in this course, you will see more about it. The present discussion is only to help you to get started on this topic, and you can practice more. So let us summarize what we have learned. We have learned indexing, slicing, and some vectorized. And for your exercise, that you take this array np outer uv. So what you do is take the above array of this np outer, that means u v transpose this array, and find the determinant using numpy. You have to figure it out. I didn't discuss that how to find determinant using numpy. This is something you have to figure it out yourself. And to figure it out, you study from this website, which the link I have given in previous lecture, learn. So from there you will get it. So I think that's all for this lecture. Thank you, and I'll see you in next session.